We open Eclipse first. Okay, so last day we have discussed about abstraction. Okay, so in abstraction we have seen interface, like why we have introduced this interface in abstraction. So to hide the main implementation, we'll use this concept to achieve abstraction. Got it? So yesterday we have seen multiple example for that. Like for this person 1, person 2, we have created this car one, right? So if we want to access like inside car, so we have created one interface. Where is that cursor? Yeah, so we have these interfaces. Okay, we have these interfaces. So in interface we have declared those methods. Okay, and their implementation is available in where? Their implementation is available in this class. So if we want to use this drive, brake, window, wheel, gear and music, what we'll do, we'll directly not call this implementation class. First we'll go to our interface, then we'll call that method. So with the help of this we are hiding what? Implementation. So if any user wants to use these methods, they will not directly come to our implementation part. First it will go to our interface, and interface internally call those methods. Okay, so by that way we can achieve abstraction. So what is abstraction? To hiding the main implementation. Got it? For example, we have this house, right? So this red one is your house. So like you have one boundary wall after that house, and you have one entrance gate. So if anyone wants to come, first they will cross this boundary, right? So there is one layer. The same way, when you are trying to use these methods in your class, what you have to do? First you have to call this layer. So if you want to enter this house, first you have to cross this boundary, then you will come to this house. The same way you will call this interface. So this is one abstraction layer. Okay, you will call this method internally. This interface will go to this whatever method we have declared here. Got it? So that way interface works with class. And then we have seen this Tesla car example also. We have seen this calculator and their implementation also. So if we have an interface, we are trying to use that abstraction concept, so we have to implement those interface in calculator IMPL. So if you are using abstraction, it means you are also performing polymorphism. You have seen whatever method you have declared in interface, the same method with same return type, same on number of argument, same order of argument, everything is same. That means here we are using method overriding as well. Got it? Now we have seen their program also. Okay, like how can we use interface in class? So you cannot create object, you cannot create object of any interface. What we have discussed, we can give only reference to that interface. Reference of which one? Reference of that implementation class. So calculator calc is what? Calculator calc type is in calculator is the type. What is the type? So calculator is one interface. Their implementation is available in which class? This calculator IMPL class. So we are giving that implementation class reference to this calculator interface, to this one. Got it? So that way we can use those interfaces in any class. Got it? And then we have called this addition method, we have called this subtraction method, we have called this multiplication method, and we have passed those value, and they have returned that answer when we have run this program, right? The same way in drive, window, gear, music, wheel, and for brake one. Got it? So this is interface. Now we have one more topic in abstraction, that is abstract class. So that abstract, so in interface we are what we'll do, we'll only declare those methods, their implementation is available in different class, right? So this is interface. Inside interface you cannot add your implementation, right? But when we'll come to the abstract class, so we have class here. So any class which contain abstract and non-abstract both. So abstract class, you can say abstract class is the parent of interface. For example, I am creating one more file here, paint. This one. Okay. If you have any doubt, you can ask anytime. Okay. Oh, yeah. Mm-hmm. 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 Yes, yes, yes. Just like once we'll discuss this abstract class, na, we'll see what is the difference between interface and abstract class. So where we'll see like in Java 8, they have introduced some feature. Like in interface, we can add implementation as well, but there is some condition for that. So we'll discuss that one also. I understand what you're trying to ask. Like in interface, we can add that implementation as well. By default, they have some default like access modifier, like we have public, private, protected, and default. So if we are creating any method inside that, so that contain only that type of access modifier. We can declare different types of modifier into that. So we'll see that one also. Okay. Yeah. So now, okay, so we have, okay, so we have created this one. So here we'll discuss, yeah, abstract class. All right. So in interface, what we have seen, we can declare only, like interface contain only declaration. So if we have 10 methods, then we can declare only those 10 methods in our interface. Their implementation will be in their implementation class. Okay. Then what is this abstract class? So it contain both abstract and non-abstract method. It means both declaration and implementation. So if we are saying abstract method, or you can say like what is abstract and this non-abstract. So if we have their declaration and if we have their implementation, then we'll say it contain both the methods. Okay. For example, so this is your interface, right? And this is your class. This is your interface, this is your class. So if we have drive method, so in interface we have their declaration only, right? We have gear, so in interface we have their declaration. But when we'll come to this abstract class, I missed that abstract word here, abstract. Okay, when we'll come to this abstract class, it contain declaration plus their implementation as well. So it contain both declaration and implementation. So if we have this abstract class, and so in the interface what we have seen, if we want to use those methods somewhere, we'll do what? We'll take reference for that implementation class, right? So we cannot create object of interface. Same way we cannot create object of abstract class as well, right? Same will use their reference. The same way we have used that reference concept when in comes to the interface one. Abstract class will do that same. Got it? So the main difference between interface and abstract class is what? It contain only declaration part, but our abstract class contain both declaration plus implementation. And for both interface and abstract class, we cannot create object. If this class is normal class, they didn't have this abstract keyword here, it means we can create object of that class, because that class is simple class. They didn't have any abstract keyword or anything. So when we want to create any abstract class, what we have to do, we have to use this abstract keyword, abstract class, then class name, and their implementation or your declaration, whatever you want to enter. Okay, so I am adding some point for abstract class here. All right, so an abstract class must be declared with an abstract keyword. So if you want to create any abstract class, what you have to do, you have to use this abstract keyword before class. So for example, you have created some class, example class, right? So what you have to do, class, then example, and then your methods and whatever variable you want to declare, right? So this one is normal class. What is abstract class? Just before this class, you have to add this abstract keyword. That's it. So now this class is what? Abstract class. Got it? So an abstract must be declared with an abstract keyword. Okay? It can have both declaration plus implementation. Got it? Or you can say IMPL also. It is fine. Right? We can't create object of an abstract class. Okay, you cannot create object of any abstract class. So these are the some important point when comes to the abstract class concept. Got it? Now we'll see, if we have abstract class and we are trying to use those methods and variable we have declared in our class, how can we use that? Okay, so again I'm repeating, abstract class must be declared with abstract keyword. It can have both declaration plus implementation, means abstract and non-abstract method as well. It cannot, like you cannot create object of abstract class as well. Got it? Now we'll see the program for that one also. So we'll open there that package. So instead we have created one com.amish.abstraction, right? So I'm creating one class. So I click go to new class. So this one is abstractIon3 abstraction 3. All right. Now what we have discussed, if we want to create any abstract class, which keyword we have to use? This keyword, abstract class. What is your class name? For example, I have created this example abstract class. Got it? Now inside this now we'll do what? Now we'll declare some methods into this example class. Got it? So if we want to add any method, if we want to add any abstract method, so we have seen in abstract class we can add both abstract and non-abstract method. So if we are trying to add any abstract method, it means we have to add this abstract keyword here, right? So abstract void m1. Okay, if we'll remove this, sorry, abstracts void m1. Okay, so if we'll remove this abstracts, it means this method is non-abstract method, right? Now I have added this abstract one, it means this one is abstract method. So we have we are trying to discuss this abstract class, right? So first we'll discuss this abstract we'll start with abstract method. So if we have added any abstract keyword, it means that class is abstract class, and inside that method if we have added any method with this abstract keyword, it means this method is now abstract method. This class is now abstract class. Got it? Now we have one more class example2. Okay, now example2 want to use this m1 method. Got it? They want to extend this property. They want to use this example class m1 method in this example2 class. Got it? Now how can we use any class in different class? If we'll go directly, if we want to use this example class in this example2, what we'll do, we'll create object, right? But we have discussed we cannot create object of any abstract class. Then we'll do what? So we have seen polymorphism concept, right? So when we have discussed that interface one, which polymorphism we have discussed that time? Method overloading and method overriding. These two topics we have discussed, right? And in interface we have discussed method overriding. When we have any declaration in our interface, their implementation is available in different class. It means they are inheriting those property. Okay, that class is inheriting that property. That is what? Method overriding, because that same method is available in that interface and that same method is available in your class as well. That's why that is method overriding. The same way, if you have this m1 method in this example class, you want to use this m1 method in your side, what will do? You will just extend this one, right? Extend example. Why you can't okay, yeah, so why you can't implement this one, this example one? Because only we can implement interface. So if we have any interface, then we can implement that one. But if we have any class and we want to use those class property in different class, where what will use? Inheritance concept here, right? So I have you, so this example class m1 method we want to use in this example too, so that's why I have extended those class. So now this example to contain this m1 method. So this is the declaration of this m1, right? Now in this example too we'll create that one. So add unimplemented method. So if you see here, we have created this m1 method here. All right, inside this m1 I am adding some sysout statement. This is example to m1 method. Sorry, this is example to m1 method. Okay, right? So we have this example abstract class, we have this example to class. Now we'll do what we were trying to use this example to in this main method here, right? So what we'll do, what we'll do, will give reference to this abstract class. So example ex equal to new, and then what reference we have to give? We have to give the child reference, because in child class we have that implementation. So where we have implementation of that method, that class is what? That class is child class, right? So example 2 is child, so we are giving reference to that class here, right? So example ex equal to new example 2. Why example 2? Because example 2 extended property, they have inherited property of which class? Example class. That's why we'll give example abstract class reference to this example 2, because example ex implementation available in which class? Example 2 class. So that's why we are giving reference, right? Now ex dot m1 m1. All right, I will run this program. If you see now, we got this. This is example to m1 method. Got it? So now you have idea, right? What is the difference between abstract class and interface? Okay. So now we'll see one more example for this abstract class one. Got it? So here we are also performing that method overriding. That same method we have declared in this example class, that same method implementation in this example too. So this m1 is override by which one? This one. That's why they are printing this line, because child 1, this example 2 1 override this m1 method, and they have executed this line. Got it? Okay, so we have discussed the abstract method. Now we'll go for non-abstract as well. So we'll create one more class here. So this is example, this is abstraction 3. We'll create one more class here, exam abstraction 4. Abstraction 4. So we are trying to create what? First abstract class. So abstract class car, right? So in car, so we have discussed constructor topic earlier or not? I don't remember. Like I confused. Like we have discussed this constructor one or not? I have discussed already that constructor part, right? Okay. Okay. So as we have seen, when we have non-static data, Either it is non-static variable, non-static method, or non-static block. If we want to access those non-static data, what is our first approach? If that non-static data, so first we have to create object. At the time of object creation, those non-static data will get the memory location for that. So after that we will be able to access those methods or those variable, right? So when we are, for example, we have this abstraction 4 class. Inside this abstraction 4, I have created some method like void abcd. Okay, and here I am printing this line abcd. Okay, if I'll run this program, we got the we didn't get anything because we have just created this method, right? So to access this non-static data, right, this abcd method is non-static data, right, because there is no static keyword in this abcd method, right? So to access this abcd method, what we'll do, we'll create object of this abstraction 4 class, right? So abstraction 4 ab equal to new this one, sorry, semicolon, then ab dot abcd. If we'll run this program, we'll get that abcd answer, right? So we have this class abstraction ab equal to new. So we know, like, if we want to create any object of any class, what keyword will use? This new keyword. Then what is this next one? What is this abstraction and that parenthesis? So this is constructor. This is constructor. What is this constructor? So that constructor will do what? When we are trying to create any object of that class internally, this constructor will give that memory to those non-static data. Got it? So at the time of object creation, we are calling that constructor. Okay, so in constructor we have total three type. One is default constructor, another one is non-parameterized constructor, third one is parameterized constructor, right? As we have seen, if you are creating any method, we can pass some value into that. So that one is, if we are passing some value, it means that method is parameterized method. We are passing some parameter into that. If that method is non-parameterized, it means we are not passing any argument into that. There is empty, there is no argument in that method. So that is non-parameter. And third constructor is default constructor. Okay, so before going to depth in this abstract class, first we'll cover the constructor one, because I thought it was covered earlier, but I don't think I've covered this one. So I'm just covering that constructor as well. So for that I'm creating one class here. I'm giving that, yeah, Amish. Okay, so we have this one. So we are, what we have seen, constructor type is, first is default constructor, non-parameterized constructor, and parameterized constructor, TIZDT. Okay, so we have these three type of constructor, right? So why we'll use this constructor? So if we have non-static data, so we have void some name method is there, and if we'll call this name method, it will print some name here, ABCD. Just got it, right? So this one is non-static data. To access non-static data, what is the first process? First process, we have to create object of that class. right? So we'll create object of this amish class amish am equal to. Now to create any object, what keyword we have to use? New keyword. After that we have to add this constructor. So this, after new keyword, whatever we are adding, it is nothing, that one is constructor. Okay, so always constructor name is same as your class name. So if your class name is amish, your constructor name should be amish. If your constructor name is amish, sorry, if your class name is amish 2, your constructor name also contain this amish 2, right? So constructor name always same as class name, that remember. Okay, now I'm just control J, yeah, control Z, done. So if we have same name as class name, then that is your constructor. So I have discussed, like we have three types of constructor. One is default one, another one is non-parameterized, third one is parameterized, right? So now first we'll see this default constructor. What is this default constructor? So it means if in your class, so we have created this class amish, it starts on line number 3 to line number 15. So if inside these class, if we have any constructor, if we have any constructor in these two, and if we didn't have any constructor in these two, right? So there is one default constructor. If there is no constructor defined in your class, then it will go for default one. So we don't have to create constructor first time. By default, when you are creating object of any class, internally they are calling this default constructor. So this amish and parenthesis is nothing, it is default constructor. Got it? What is default constructor? If there is no constructor declared in your class, that is default constructor. And if we have declared, like if I have declared this amish and this, it means when we'll create this object, if we inside constructor we will add some program, right? So this is amish tructor. So if, okay, sorry, I have to add this this double quote, right? I've added the single quote, right? So if we'll run this program, so I have just created object of this amish, right? If I'll run this program, just see what output we are getting. They have printed this. This is amish constructor. So what is the definition for this one? At the time of object creation. So here we are creating object of this amish class. So at the time of object creation, they are calling constructor here. So if we have any constructor, so what is the constructor name? Same as class name. Okay, so if we are creating any object and if we have any constructor, so this one is what type of constructor? This one is non parameterized constructor. Why this is non parameterized constructor? Because we haven't passed any argument into that, right? And if we'll pass some argument, it means amish. So always constructor name is same as class name. I am passing one integer argument here, right? And then I am printing that line. So this is parameterized constructor. Okay, I'm trying this one. So I am again creating one constructor. So always when we are creating object, we have to give some unique name into that, right? For their identity. So this is am2. We have this constructor as well, right? This one is parameterized constructor. Parameterized constructor means we are passing some parameter. We are passing some argument into that. That is parameterized constructor. Okay. So here we'll pass 10. And let me print that parameterized constructor and I. Right. Let me run this program. If you see here, we haven't called these two lines. We haven't called this one. We haven't called this one. Then how we'll get that output? Because at the time of object creation, we are calling that constructor. So this one is not default. This one is now parameterized one. This one is non-parameterized. So if we are passing any parameter, that one is parameterized constructor. If we are not passing any parameter, it is non-parameterized constructor. And if we didn't have these two, then by default it will go to default one. If I'll comment these two, right? So now this constructor is commented in this class. So now it will go to which one? It will go to default constructor one. If you have declared parameterized or non-parameterized constructor in your class, it means it will come to these two. And if you didn't have any constructor declaration in your class, so by default always at the time of object creation it will go to default constructor. So Java inside, like when we are creating that class, internally they are creating that default constructor. You don't have to declare your own constructor, right? Always. If you want to add some logic in your constructor, so at the time of object creation they will come to this one, they will come to this one. Okay. So you understand now what is this constructor, what is the use of constructor. So always if you are creating any object of that class, it means you are creating, you are at the time of object creation you are calling constructor, either default one, either parameterized one or non-parameterized one. Got it? Any doubt? Okay. So now I am doing what? I'm just uncommenting these one. Sorry. Oh, it's set. Yeah. So this one is non-parameterized. This one is parameterized. And if there is no constructor declaration in our class, it means it will go to default one. Got it? So now we'll come to our abstraction part. I've just given that brief note on that constructor one. We'll see different example as well, right? So we have this abstract class car. So inside this abstract class, you can create constructor as well for this car one. All right, like this car. Yeah, so if we are creating any constructor, if you'll see, I have just like in, if you see this amish.java file, I have given this class name, parenthesis, and their body. Same way, if you are creating any constructor for abstract class or non-abstract class that contains some body, right? It means some implementation, right? Implementation. Okay. So when we have interface, there is no implementation in interface, but when will come, you cannot create this constructor for interface, right? But when we'll come to this abstract class, we can create in constructor inside that class as well. Just we have seen what is the class name, what is the constructor name, same as class name. If you see, this is car, this is car, we cannot give here like car 1, it will give error. Like return type for this method is missing, so they will not consider this car one as this car class, right? They will consider this one is some method. So always just ensure that your constructor name is same as class name. So this one is your Non-parameterized constructor. You can create parameterized constructor as well. Like you'll pass some integer value and your body. So this one is your parameterized constructor. Got it? So this way you can declare constructor in this abstract class as well. But in interface, you cannot add these type of constructor because that one is interface. This one is class. So only class contain constructor, not the interface. All right. So I'm just removing this one. So now this is our abstract class car. So inside car, I'm creating some method like void gear. Okay. So gear. So this one is our method. I'm adding this is out statement. So this is abstract class gear. All right. Now I'm adding constructor as well. I'm not passing any argument. I'm printing this line again. So this is car constructor. Okay, so I have declared I have added this gear, I have added this car here, right? Now what we'll do, so this is class, so we want to use these property where in some other class. So let me create one more class abc, sorry, abc extend, because we are trying to extend that class property car in this abc, right? So earlier we have created this gear method and this constructor one, right? So here we'll do what? Now this abc contain all the methods that we have declared in this car class. All right. Now I am adding yeah, so let me remove this one. We have discussed this one earlier. Remove this one as well. Yeah. So inside this abstract class, we have one method, we have one constructor. Now we have extended those property in ABC. Let me create one more method here. Void break. Sorry, not the break drive. Yeah, zero argument. This is drive method. Oh no, this one is non-abstract. Now we'll create one abstract one, right? So there is one abstract, one non-abstract. So if there is no abstract keyword in that method, so this one is abstract method. Upper one is non-abstract method. Non-abstract method. Got it? If we have any abstract keyword, that means that is abstract method. If there is no abstract keyword, that means that is not abstract method, non-abstract method, right? So we have these three feature in this car class. So see, as we have discussed, abstract class contain both declaration plus implementation. So this is declaration, this is implementation, so it contain both. Now we have their implementation, but we didn't have this drive implementation, so we'll implement this drive. So if I'll hover to this one and we'll just click to add unimplemented method. So if you see, they have implemented only drive method. They haven't implemented this gear one, right? Because gear one already have their implementation, right? So if there is some declaration, there is some implementation, right? So in where we are extending, like where we have their implementation, that place will add only implement those methods, those we didn't have any implementation. So this drive method didn't have any implementation. That's why in this ABC class we have added their implementation. Got it? So if this is interface, so that time we have to implement all the methods that we have in that interface. But when we'll come to abstract class contain both implementation plus declaration. So this is your declaration. So you have only declared this drive methods. So we have to add their implementation in this ABC class. So drive implementation. Got it? This gear already have their implementation. That's why we will not add their implementation in this class. All right. Now, we now will use this abstract class, right? So what we'll do now, as we have discussed, we cannot create object of an interface and abstract class as well. So car C equal to new ABC. Why this one? Because this implementation, this drive implementation available in this ABC. So now this ABC contain all these and this one because they have extended car property, right? Now we'll do what? C dot drive. Okay, let me run this program. See, this is car constructor. Okay, drive implementation. So we haven't called this constructor. This is car constructor. Why they have printed this line? This is car constructor because when we have given reference, when we have given reference for this ABC to this car, at the time of that they have initialized this car, and that's why they have printed this. This is car constructor line. Okay, and then we have C dot drive. So in this car C we have drive declaration. Their implementation is in this class. So C dot drive, they have printed this line. Now we have one gear method. We haven't called that one. So we'll do what? C dot gear. If I'll run again, see, now first they have printed this car constructor, then drive implementation, then gear one, right? The same way when we are calling that method in interface, abstract class will do that same process is there. But the main difference is abstract class contain both abstract and non-abstract method. So this is your abstract method. This method contain abstract keyword. This method didn't have that abstract keyword. And one more point, in abstract class you can add declaration plus implementation as well. Let me give you one diagram view also. So this is interface. Okay, so this interface contain what? Only declaration. Interface contain only declaration, right? Now this is our abstract class. This is our abstract class. So abstract class contain both declaration plus implementation. Got it? So this whole circle, this whole is your abstract class. So abstract class contain both abstract and non-abstract. Where is it gone? Sorry. Implementation. Oh, why it's removed? Okay, got it? So abstract class, just assume abstract class is the parent of interface. They contain all interface plus their implementation as well. I think let me have to give one example. So see, this is your abstraction, this is your interface. Got it? So this whole, so just assume this one is your earth. So earth, inside earth we have different country, right? So one country is interface, and this whole earth is what? Abstract class. Just understand in this way. Got it? So abstract class contain this interface plus their implementation, right? Because this interface only contain what? It contain only, and it contain, so this interface contain declaration. This abstract class contain implementation plus declaration. Got it? So that is the main difference. And it contain non-abstract method. So in interface there is no abstract method, but in abstract class we have non-abstract plus abstract method both. Got it? So now it is clear now what is the main difference between abstract class and interface. This abstraction, sorry, this abstract class and this interface following which polymorphism property? Both method overloading, method overriding, right? If you are extending any class, that method already present in child and parent as well. Child will do what? They will override the parent one. And if we have that method in parent, if we have that method in child as well, but argument is different, it means that is method overloading. Got it? So any doubt on this interface and class, sorry, interface and abstract class? If you have any doubt, we'll repeat again. Okay. Now we'll see, now we'll add some point like the difference between abstract and interface. I will add some point into that. Let me divide this into two parts. What is the time? Okay, it's 10:01. No? Okay, we'll do. Okay, we'll cover the difference part tomorrow. Okay, actually time already crossed 10 to it's there. So we'll tomorrow we'll see the difference between abstract class and interface. Like orally I'm saying like what is abstract class? Abstract class contain both abstract and non-abstract method, but interface like Java 8, like after Java 8, we can add implementation in our interface as well, but only default method. So we'll see that their program tomorrow as well, right? So abstract class doesn't support multiple inheritance, right? in multiple in inheritance we have one inheritance where we have seen like the same class can inherit multiple class same time or not, so it is not supported. For example, so if we have some class a wants to extend b comma c comma d like that, right? So it is not acceptable in Java. Okay, this one is what? This one is your multiple inheritance, right? So like when we'll come to this class concept, it is not acceptable. But if you have any class like class A, and if you have 4 5 interface, right, same time you can inherit, you can implement I1 I2 comma I3 like that. So in abstract class multiple inheritance is not supported, but when we'll come to that interface, in interface multiple inheritance is possible, is not possible. You got it now what I am trying to say? If you are trying to extend multiple classes same time, it is not possible. So this is for class, this is for interface. So when you have multiple interface and you are trying to implement multiple interface in the same class, you can do that. So that is multiple inheritance example. So last, like when I have discussed inheritance part, I told you now multiple inheritance will discuss in abstraction concept. So interface is supporting multiple inheritance, but this abstract class doesn't support this multiple inheritance, right? Got it what I'm trying to say? If you're trying to do this like this, it is not possible, but when we have different interface we can do that. And abstract class contain implementation as well, but in interface we didn't have any implementation. And if we are trying to create any abstract class, we have to use abstract keyword. If you are trying to use interface, like if you are trying to create interface, we have to use interface keyword. Like, so that is the main difference between abstract class and the abstract class and interface. That is the main difference. That's it. So tomorrow we'll discuss some program for like Anup asked that question, right? So abstract, like for the default and static method, like interface contain that one. So we'll discuss that one also. Difference one and the next one. So after this abstraction, one topic is pending, that is encapsulation. In Opps we have one pending topic, that is encapsulation. So tomorrow we'll discuss that abstract class and interface difference and the encapsulation part. Okay, so that's it for today. Thank you for joining. Yeah, have a good day.